Hello, my name is Truls Hansson. I'm a PhD student in the Monthly project, and I would like a minute of your time to talk about farting lakes.
Everyone farts. Most of you probably know that animals fart too. But did you know that lakes and in fact several other types of environments also fart? The main component in farts is a gas called methane, which is an invisible, highly flammable, and contrary to popular beliefs, odorless gas. The bad smell in farts actually comes mainly from sulfuric compounds, which can be found in different concentrations from day to day in your stomach, and this is why you sometimes have really smelly farts, while other times hardly can smell your farts at all. Methane is usually produced when living, or more commonly previously living, that is, dead things are decomposing in places where there is no oxygen. For example, deep underground, at the bottom of lakes, or inside your guts. This process is mainly carried out by various types of microorganisms. Unfortunately, methane is what we call a greenhouse gas, and a powerful one at that. Most of you have probably heard about global warming by now, and many of you might also know that it's caused by something called a greenhouse effect. This is when heat from the sun is trapped in the Earth's atmosphere by greenhouse gases. There are several different types of greenhouse gases. The most well known and at the moment important one is called carbon dioxide or CO2. Methane, however, is almost 30 times as powerful when it comes to global warming as CO2. Like CO2, methane concentrations in the atmosphere has increased considerably since we humans started our industrial revolution about 200 years ago. Unlike CO2, however, which is mainly released as we humans burn things in order to get warm or make cars go fast, a lot of the change in atmospheric methane is caused by how we have changed the environment around us, such as lakes and wetlands. So, when scientists are trying to understand how global warming will affect the climate in the future, the important questions are: what produces methane, how much is being produced, and especially, how much will be produced in a warmer climate? Because methane is usually produced in places where there is no oxygen, it is very easily influenced by the processes that produces oxygen, such as photosynthesis. Now, photosynthesis is usually dependent on light. So, if a lake becomes dirty from pollution, organic material, or its surface gets covered by plants, there will typically be less photosynthesis, which usually means more methane production deeper down in the lake. However, things are a bit more complicated than that because things such as wind can cause waves which splash the water around and make sure that oxygen-rich water reaches all the way down to the bottom of the lake and prevents methane from being formed or destroys existing methane in a process called oxidation. Recently, things have gotten even more complicated when scientists discovered that methane apparently can be produced in the presence of oxygen after all. But this quickly gets quite complicated, and to be honest, we scientists don't yet actually know quite how that works. Ironically, however, it does seem to be related to a previously discussed process, namely photosynthesis, with more photosynthesis creating more methane. Ask us again in a few years when you guys start university, and we'll hopefully have it figured out for you. Or maybe you will. We also briefly mentioned that methane in water can be destroyed in a process called oxidation. This mainly happens while methane is in the water, and as soon as methane escapes into the atmosphere, it will be around for at least a few years. Thus, from the time methane is being formed and enters the part of the water column that has lots of oxygen in it, it is basically in a race to get to the surface as quickly as possible. We also previously mentioned the role of wind in preventing the creation and destroying methane deeper down in the lake. Now, however, wind speeds can actually help methane by getting it faster into contact with the atmosphere. All in all, understanding how much methane is being produced and how much actually escapes into the atmosphere is a very complex question. And to answer it, scientists usually turn to models, which will be generally covered by another video in this series. However, in order for models to work, we need to know a lot about the processes that influence the methane that gets into the atmosphere. In this presentation, we have now briefly gone through some of the more important ones of these processes. I hope you now have so much clearer understanding of what methane is, where it comes from, and how various processes can influence how much of it ends up in the atmosphere. This is Truls Hansson signing out.